Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we're going to discuss in our today's video is parabola under conic sections. In this video, we want to look at the graph of a quadratic function. The most general form of a quadratic function is ax square plus bx plus c. The graph of the quadratic functions are called parabolas. Okay, here are some examples of parabolas. All parabolas are vaguely U-shaped and they will have a highest or a lowest point like this. This end point is called vertex. Parabolas may open up or down or may not have x-intercepts, and they will always have a single y-intercept. These are the key points you must make a note on parabolas. Also, please note as well that a parabola that opens down will always open down, and a parabola that opens up will always open up. In other words, we can say that a parabola will not all of a sudden turn around and start opening up if it has already started opening down. Does this make sense to you? Similarly, if it had already started opening up, it will not turn around and start opening down all of a sudden. Okay. And when you're seeing a parabola, you may also see a dashed line with each of the parabola. The dashed lines with each of these parabola is called axis of symmetry. Here I have mentioned it in red. Every parabola will have an axis of symmetry. The graph of either side of the axis of symmetry is a mirror image of the other side. Please make a note. This means that if we know a point on one side of the parabola, we will also know a point on the other side based on the axis of symmetry. Okay, let us see how to find this point once we get into some examples. We should probably do a review on the intercepts. So intercepts are nothing but the points where the graph will cross the x or y axis. Am I right? We also we can see the intercepts. It will touch the axis without actually crossing it. Okay. Finding intercepts is fairly simple process. In case if you're going to find the y-intercept of a function, all we need to do is set x is equal to 0 and evaluate to find the y coordinate. In other words, we can say that y-intercept is a point 0, y, or any constant will be there. We find x-intercepts in pretty much the same way, right? We set y equal to 0 and solve for the resulting equation for the x coordinates. So we will need to solve the equation f of x is equal to 0. Okay, let's get back to the parabola. There is a basic process we can always use to get a pretty good sketch of a parabola. Okay, let me give you the steps. So in case if you're going to sketch a parabola, first thing is you have to find the vertex. It is very simple. There are several methods for finding it. Okay, we can discuss it separately. After finding the vertex, you have to find the y-intercept, the point where the parabola touches the y-axis. And step 3 is to solve f of x is equal to 0. Whatever equation you're getting, you have to set that equal to 0 and find the x coordinates of the x-intercepts in case if they are existing. And please make sure that you have got at least one point on either side of the vertex. This is that will help us to make sure we get somewhat accurate sketch. If the parabola has two x-intercepts, then we'll already have these points, no? If it has only one x-intercept, or if there is no x-intercept, we can either just plug in another x value from the graph, or we will be using the y-intercept and axis of symmetry to get the second point. And finally, connect all the points and sketch the graph along with the vertex. At this point, we have gotten enough points to get a fairly decent idea of what a parabola will look like. Okay, now there are two forms of the parabola that we will be looking at. This first form will make graphing parabolas very easily. Unfortunately, most parabolas are not in this form. And the second form is the most common form and will require somewhat a bit work to sketch the graph of a parabola. Okay, let's first take a look at the first form of the parabola. Please take a look at this first form of the parabola. F of x is equal to a x minus h the whole square plus k. Here there are two pieces of information about the parabola that we can instantly get from this function. First thing is, if this a is positive, then the parabola will open upwards. In case if this A is a -1, then the parabola will open downwards. So this is the first information you should know about this one. And secondly, vertex of the parabola is the point h, k. So please be very careful with the signs when getting the vertex here. Okay. So whenever you get questions of this format, you can easily identify what the vertex is without any calculation. Okay, let us see some examples under this. Here is an equation example. Okay, we can just go through the process what we just discussed. Okay, first we need to find the vertex. We will need to be careful with the signs, however. Comparing our equation to the standard form. So we can say that in the place of h, it is replaced by -3 because negative will give plus sign, no? And in the place of k, we have 8. So h is equal to -3 and k is equal to 8. Actually, this is plus sign, no? So h is equal to -3, k is equal to -8, since that is the only way to get the correct signs in our function. Therefore, the vertex of the parabola, I'm going to write this as a pair. Step 1 is to find the vertex. Now, next step, let's find the y-intercept. There is nothing more than a quick function evaluation. I'm just going to replace x by 0. For all the x, you have to replace by 0. By substituting this, you'll be getting 9 times 2, 18 minus 8. So y-intercept is 0, 10. When x is equal to 0, y is equal to 10. So our y-intercept is 0, 10. Hope you're clear till this step. Next, we need to find the x-intercepts. This means we will need to solve an equation. However, before we do that, we can actually tell whether or not we will have any. Before even we start to solve the equation. In this case, in the place of a, we have 2, which is a positive one. So we know that the parabola will be opening up. Also, the vertex is a point below the x-axis. Both are negative. So we know that the parabola will have at least a few points below the x-axis. It will open up. Therefore, since once a parabola starts opening up, it will continue to keeping opening up. Eventually, we will have to cross the y-axis. Am I right? Hope you are getting my point. In other words, there are x-intercepts for this parabola. So let's find what is that. X-intercept is nothing but solving for x when y is equal to 0. So I'm going to equate this to 0 and solve for x. Let's do some arithmetic here. To find the x-intercept, you need to solve this equation. We solve equations like this when we were solving quadratic equations, right? Hopefully you remember how to do them. Add 8 on both these sides so that you can shift this number to the left side, and divide both these sides by 2 so that you can get rid of this coefficient 2. And then you have to get rid of the square. Dividing both these sides by 2. Taking square root on both these sides so that we can get rid of the square from the left side. So square root of a positive number under the quadratics would give you plus or minus 2. You have to add plus or minus sign before your answer. And then subtract 3 from both these sides so that you can isolate x on one side of the equation. So you'll be getting 2 points, either one by adding and one by subtracting. So minus 3 plus 2 and minus 3 minus 2. So I'm getting 2 answers. X is equal to -1 and x is equal to -5. So our two x-intercepts would be -5, 0 and -1, 0. Now at this point we have got points on either side of the vertex. So we are officially done with finding the points. However, let's take a little bit about how to find a second point using the y-intercept and the axis of symmetry, since we will need to do that eventually. First, notice that y-intercept has an x-coordinate of 0, while the vertex has an x-coordinate of -3. This means the y-intercept is a distance of 3 to the right of the axis of symmetry. Since that, we will be moving straight up from the vertex. Now, the left part of the graph would be a mirror image of the right part of the graph, as I said to you about the axis of symmetry. So, since there is a point at y equal to 10, that is a distance of 3 to the right of the axis of symmetry, there must also be a point at y equal to 10. I mean, that is a distance of 3 to the left of the axis of symmetry. So, since the x-coordinate of the vertex is -3 and this new point is a distance of 3 to the left, its x-coordinate must be just include 3 more points. It would be negative 6. Am I right? The coordinate of this new point are then negative 6, 10. You can also verify this point whether it is correct or not. The coordinates of this new point are negative 6, 10. Okay, you should get a value 10 if you're going to plug in negative 6 here. Replace all x by negative 6 and check whether you're getting 10 or not. I have done the calculation and I'm getting 10. So we are correct. Note that we usually don't bother whether the verification with this verification, but it is fair and good if you're just verifying the point. You need not mention this in your steps. Okay, now it's time to sketch the graph of the parabola. All you have to do is plot this vertex, Y-intercept and X-intercepts and this point, and axis of symmetry is there. So this is how the graph will look like. This is just a rough diagram. You can plot it on the grid. You'll be getting a perfect curve. Notice that we included the axis of symmetry in this graph, and typically we won't. It was just included here since we were discussing it earlier. Hope you got an idea on this one. We can discuss more about the parabolas. So this is how we form a parabola. So in this form, the sign of the A will determine whether or not the parabola will open upwards or downwards. Okay. So far we discussed examples where we can identify the vertex directly. We can continue the same topic in the next video too. In case if you get any query regarding this video, kindly let me know. See you in the next video. Have